In this video, you are going to be learning about the early ideas in atomic theory. By the end of this video, you should be able to state the postulates of Dalton's atomic theory and use these postulates to explain the laws of definite and multiple proportions. Dalton's atomic theory has 5 points to it. The first is, matter is composed of exceedingly small particles called atoms, and an atom is the smallest unit of an element that can participate in a chemical change. The second, an element consists of only one type of atom, which has a mass that is characteristic of the element and is the same for all atoms of the element. A macroscopic sample of an element contains an incredibly large number of atoms, all of which have identical chemical properties. Atoms of one element differ in properties from atoms of all other elements. A compound consists of atoms of two or more elements combined in a small whole number ratio. In a given compound, the numbers of atoms of each of its elements are always present in the same ratio. And atoms are neither created nor destroyed during a chemical change, but are instead rearranged to yield substances that are different from those present before the change. And this last statement is the law of conservation of matter. Now, not all of Dalton's atomic theory is entirely correct, but it was a huge step forward from what they had before, with the elements being earth, air, fire, and water. So this was a very big step forward for the scientific realm in terms of understanding what matter actually was. Although there are some things that have been determined to be not entirely true, it is still considered the basis for modern chemistry. The law of definite proportions, also sometimes called the law of constant composition, states all samples of a pure compound contain the same elements in the same proportion by mass, or the number of atoms of the elements in a given compound always exist in the same ratio. The law of multiple proportions is talking not about a single compound, but when two or more elements react to form more than one compound. So we talked about how we can get transition metals to form with multiple charges and therefore have multiple formulas. For example, copper and chlorine can react as CuCl or CuCl2. This is what the multiple proportions is talking about. When two elements react to form more than one compound, a fixed mass of one element will react with masses of the other elements in a ratio of small whole numbers. In this case, our fixed mass is 1 gram of copper, and the amount of chlorine is what's changing, and the amount of chlorine that's reacting with the fixed 1 gram of copper is in a whole number ratio, 2 to 1.